Chapter 2, Section 1, Question 0. There is no question 0, so hey, we're going to go over the degree of a monomial. So this is a skill you should have learned in a previous math class, the degree of each term. So here we have a coefficient, a number in front, a variable, a letter or a symbol, and an exponent, the number in the upper right corner. So this one has an exponent of 7, so therefore we're going to use D for degree. The degree is 7. The end. This one here has multiple variables, so what we're going to do is we're going to take all of these numbers, and we're actually, just like in chapter 1, it says multiply, but you really add. We're going to add 5 plus 3 is 8, plus 8 is 16. The degree of this is 16. Here, again, many exponents. Notice that here we have an invisible exponent of 1. You might want to write that in because a lot of people will forget it and think it's a 0. But remember from chapter 1, if that's a 0, then the entire term becomes 1. So here we have 3 plus 1 plus 2. 3 plus 1 is 4. 5, 6. The degree of this is 6. And here, even though there's a denominator, all of the variables are in the numerator, and we have 5 plus 13 is 18. So the degree of this is 18. Chapter 2, Section 1, Question 1. We're going to combine like terms. You may have done this in previous math classes, but I want to go over that we're going to take this a little slower than normal. Here we have the expression versus equation. It does not have an equal sign. It has it with parentheses. Next, we're going to rewrite this without parentheses. This first set of parentheses can just be dropped, and then using the distributive property from chapter 1, we're going to get rid of the second set of parentheses. Right here, this is where a lot of students make mistakes. It's going to continue going until chapter 6. We're going to distribute the negative there. Now we're going to combine like terms, and when we write the answers, we want to make it so that it is in descending order by degree, which is why we just went over degree. So first, I can put my x cubes together with my x cubes. What you might want to do is underline the x cubed term and underline the x cubed term. Notice that I underlined the sign in front of it. Some people also want to put like a box around it so that they can see that this term goes with this term. 7x cubes minus 5x cubes gives me 2x cubed. And then other people want to double underline this or make it into like a floofy box or something. Remembering to, here, make sure that you encompass the symbol in front of the term. This is a positive 12x and a minus 20x. And 12 minus 20 gives me negative 8. And we have the x. When you're adding and subtracting, you combine like terms, meaning that the variable portion of them is the same, and you don't put together the exponents. You only put together the coefficients. If we were multiplying from back in chapter 1, then we would change the exponents. Here, again, with parentheses to get to without parentheses, you want to have the distributive property. Some people like putting little rainbows on top. That is totally fine. Remember, when you are multiplying here, you want to multiply the negative here. So we get negative 24x. And a negative and a minus sign will work together, and a negative will make it a positive. 6 times 7 is 42. I intentionally put 6 and 7 here because it is one of the most missed multiplication problems. Here, again, I'm going to put my x's with my x's, making sure to underline the negative there. 6 minus 24 is negative 18x. And this is a plain number with another plain number. Negative 10 plus 42 gives me 32. And that is my answer. Notice the steps with parentheses, without parentheses, and then combining like terms. Chapter 2, Section 1, Question 2. We're going to solve algebraic equations because that is the point of algebra. You'll notice that here I have fractions and decimals in the front. Darn it, we're going to have to deal with that. And the college professor has said that before we start anything, we want to make sure that we clear those fractions or decimals. In this case, we have decimals. There's one decimal here, there's one decimal there. In order to get rid of that, I can multiply it by 10. And then I can multiply this by 10. Notice that if I just had 10 minus 0.2, that would actually be a subtraction problem, so I put parentheses around that. To make sure that I'm multiplying, I can also put parentheses around this, but this is important because we don't actually want to subtract by accident. 10 times 0.3 gives me 3, and 10 times negative 0.2 gives me negative 2. We are now back where you should have been in Algebra 1. We're going to use the distributive property from Chapter 1. Now, we'd like to get the x's isolated. So I have x's on the left and x's on the right. In order to make sure that the x's are positive, we'd really like to use the smaller of them. So positive 6 is larger than a negative 10x. So we want to move the negative 10x over. Remember, we're using the additive inverse so that these will cancel. You don't have to draw the line through to cancel it. And then here, I want to get the x's, since they're on the left, I want to move the numbers to the right. Again, you do not have to cancel out. 6x plus 10x gives me 16x equals 6 plus 21 is 27. Divide both sides by 16, showing this wonderful work, which is going to help us in our college classes. And we have, write the answer. Now, we want to check. 27 can divide by 3, but 16 can't. 27 can divide by 9, and 16 can't. 27 can divide by 27, and 16 can't. We can't reduce that, so that is our answer. I am totally okay with you having an improper fraction, which is a top-heavy fraction. Now, to check this answer, I'd like to use the calculator. So I have 27 over 16, and one of the ways to check an answer in algebra is to take that and plug it back in. So, on button in the lower left-hand corner, I'm clearing off everything. I'm going to put in 27 over 16. With all calculators, you can put 27 divided by 16, and then hit the store button, STO, it's above the on button, and then the X button, which is right next to alpha, and that says 27 over 16 stored in for X, and enter. It will then give me a decimal that is equivalent to 27 over 16. Now, I'm going to type in the original left-hand side, 0.3 parentheses 2, again the X button, minus 7, and parentheses, enter. Then I'm going to write the original right-hand side, negative. Now, be careful, this negative sign and this minus sign may look the same, and you might think about them the same way, but the calculator needs them to be different. So because there's nothing actually in front of this, I have to use a negative 0.2 parentheses, 5x minus 3, and parentheses. And as I get these answers, it says the left-hand side is negative 1.0875, and the right-hand side is negative 1.0875. If you wanted to do this by hand, that would also work. Chapter 2, Section 1, Question 3. In the last problem, we had decimals. Now we have fractions. There are many ways to clear the fraction. However, to support us in Chapter 6, which is coming up, I want us to make a common denominator. We have a denominator of 4 and a denominator of 6. If we take a look at those two numbers, we can make a very small multiplication table. And we can multiply it by many numbers. 4 times 1, 6 times 1. Lowest common denominator, we want to find the first place that they meet up. So this is the smaller number, 4 times 2 gives me 8. Now this is the smaller number, and so 6 times 2 gives me 12. 8 is smaller than 12, so 4 times 3, we're going to take it one more step, and we get 12 on both of them. That is our lowest common denominator. We want to multiply to create a lowest common denominator. So if we have common denominators, that is a wonderful thing when adding and subtracting fractions. So in order to get a 12, I have to take 4 times 3. So I'm going to multiply this by 3 on the bottom, and to be fair, I'm going to multiply it by 3 on the top. We actually learned about this in chapter 1. It is a multiplicative identity. 3 divided by 3 is 1, and multiplying by 1 doesn't change anything. Here I have the 6, and 6 times 2 makes it 12, so I'm going to multiply the denominator by 2 and the numerator by 2. 2 over 2 is 1, so multiplying by 1 does not change anything. Now, I want us to think about something like 1/7 plus 2/7. It has a common denominator. When we add 1/7 and 2/7, we will get 3/7. Because of the equal sign, we can actually do something. We can multiply everything by 7, which will actually, just like little laser beams, pew pew, get rid of all the denominators, leaving us with 1 plus 2 equals 3. This is still a true statement. Just like this was a true statement, that's why they can be equal to each other. So here, as long as we have an equal sign and common denominators, that is a legal move. Some students want to show their work, so you could multiply everything by 7. And that's why this would cancel out, and this would cancel out, and this would cancel out. You would multiply to each term, a term being separated by either a plus, minus, or equal sign. Another way is one of our college professors actually multiplies the entire thing by 7. Normally, this causes problems because people forget to multiply all the way across. So I do not teach that method, but I did want to show it to you. So anytime we have an equal sign and common denominators, we can get rid of those denominators. I have an equal sign, and this is actually one big long term because I can extend this vinculum out. So this is one big term, and that's one big term. We have common denominators on both sides. So pew, pew, they can go. 3 times 3 is 9. Don't forget this negative here, it's very important. And 5 times 2 is 10. You're going to find that as we approach, especially chapter 5, that you can't really multiply 3 things together at the same time. You'll have to pick 2 of them, preferably the 2 ones that go together nicely. So here we have 2 sets of monomials. We want to put those together and then leave the binomial here so that we can use the distributive property. This has parentheses, so we need to get rid of them by multiplying. 9 times 6 and 6 times 9 is another of our most difficult math problems for multiplication. 12 times 9. If you need to do that, make sure that it's not in the middle of this problem. I'm doing it off to the side. Now, I have x's on both sides. I want to move the smaller one. This is positive, this is negative. Negative is smaller than positive. I'm going to move it over. Since I've moved the x's to the left, I'm going to move my plain numbers to the right. If you want to do that in 2 separate steps, that's fine, but I am also okay, as long as you do not get confused with you moving them over at the same time. 54 plus 10 gives me 64x. Those canceled, and here 108 minus 10 gives you 98, dividing both sides by 64. Now, we'd like to see whether or not this reduces. I see that they're both even, so I think that they can both divide by 2. So if I divide that by 2, I will get 49 over 32. 49 breaks up into 1/7 or 49s. A 1 will work with anything, but it doesn't help us to reduce. 7 doesn't work nicely with 32, and 49 is too large for 32. So therefore, we can do that. Now, there's another way. For those of you who have your calculator, you could do 98 divided by 64 and put in 98 divided by 64 and then hit math, enter, enter. And it will tell you it's 49 over 32. It will reduce it for you using math, enter, enter. Math is this button on the left-hand side, and enter is where the equal sign would be normally. Now, to check this, remember that we can take the 49 over 32 Since I already have it there, I can just immediately go to store x, enter. And then I'll type in my left-hand side. I can put in 3 divided by 4. If you have a newer operating system, you can hit alpha y equals, and it'll give you the first option is 1:n/d, which is numerator over denominator. It'll give you a top and bottom fraction just like this, and you can put in 3, down arrow 4, right arrow to get past that, and then parentheses 6x minus 12. Remember, if you don't have that newer operating system, you can have this as 3 divided by 4, and it'll just be written as 3/4. I hit my equal sign, so I want to hit enter. Then on the right-hand side, remember, I want to make sure I get that negative sign, which is different from a minus sign. Negative 5 divided by 6, parentheses, x plus 1, and parentheses. I got the same number for the left side and the right side. It's correct. Chapter 2, Section 1, Question 4. We're going to learn some new vocabulary. Conditional. We've actually been solving conditional problems this entire time in algebra, meaning that there is a condition that makes the left side equal to the right side. And sometimes that condition is when x is equal to a horrible fraction. A contradiction, something that's not true. An identity. We dealt with identities back in Chapter 1, where the left side and the right side are exactly equal to each other. We're going to be doing some work to solve them. We'll get the answer, x is equal to a number. This is how we've been solving all of our algebra equations so far, and that type will be a conditional. We have been dealing with conditionals for a long time. But we're going to show our work until we get a number either equals a number or does not equal a number. Let's see what this one is. Now, I could get rid of the decimal first, and the way that I would do that is I would multiply it by 10. Since this is all being multiplied, that is one large term. This is separated by a plus or minus, so I need to multiply this one separately from this one. And now, I will get 5 times 2x minus 3. Notice that since I already multiplied this by 10, I don't also multiply in here. And I get 10x plus 10. And then we use the distributive property, and we get 10x minus 15 is equal to 10x plus 10. You might say, I already know what the answer is, because the left and right sides are not equal to each other. But notice that I and the college professors want you to continue going until you get a single number equals a single number. So if you look here, I want to get rid of those x's. It doesn't matter if you move the left or right. Normally we have to move the smaller one. They're exactly the same size. So we get negative 15 equals 10. Hey, we noticed that negative 15 does not equal 10. You may leave it as an equal sign. You may put a slash through. I am okay with either one. Then you will have to write the answer, no solution, because there is no number that you can plug in that will make the left side equal to the right side. So we have the work to number equals number, or not equal number. The actual answer is no solution, and then the type, we're going to have you circle it, is going to be, this is a contradiction. I think that this is going to be an identity problem. So, once again, I can clear those decimals. That is a wonderful idea to start off a problem. Now, if you want to, you could put parentheses around here instead of multiplying each individual one, and then you'd have to distribute. It'll do the exact same thing. So 10 times 0.5 gives you 5. And we're going to have to distribute. And this gives us a 10 in the front, and you will again have to distribute. That will give us 10x minus 15 equals 10x. Remember, 10 times a decimal, we'll move the decimal over one place, and it'll give you 10x minus 15. And many of you might want to stop and say, hey, I know that the two sides are equal. I know what the answer is already, but remember that we want to have a number equals a number. So, subtracting that 10x on both sides, we get negative 15 equals negative 15. That is an infinitely many solutions, so the actual answer to this is infinitely many solutions. Now, when you get to your college class, every book is slightly different. Infinitely many solutions is what our textbook uses for these types of problems. Some of the college classes just use infinite solutions, but hey, in this class, you're going to use infinitely many solutions because they change college math textbooks all the time. The type is identity, and you're going to have to circle that on your homework, on your quizzes, but this is an identity. This is the type of problem, but infinitely many solutions, that's the answer. This is the work you need to show. Contradiction is the type of problem. No solution is the answer. And all the work until you get number equals number is the work that we're looking for. Chapter 2, Section 1, Question 5, Type 1 of 2. These are word problems. So the population density of the US can be estimated using this equation here, where you use t equals 0 for the year 2000, t equals 1 for the year 2001. So t is the number of years, and it's the years since 2000. You're going to see this type of notation from here all the way up through your college classes. So we're trying to introduce some of that now, which is one of the reasons it's in question 5. So here, determine the population for the year 2016. I need to know what the t is. So since t is 0 is the year 2000, 2016 minus 2000 gives me 16. Therefore, t equals 16. We're going to take this 16 and we're going to plug it into this formula. Remember, if there's stuff on the left and stuff on the right, formula plug work answer, we're actually going to use p equals 0.82 times t. T is 16. We're going to plug it in because plug work and answer is a wonderful thing. And here, we're going to want our calculator. If you want to do plug work and answer, then we're going to take this and use order of operations. 0.82 times 16 will give us 13.12 plus 78.5. Add those together. Since I have a 13.12 here in the calculator, I can just add 78.5. And I will get 91.62. Now it says determine the population density and label. Unfortunately for this problem, it doesn't tell us the label. It actually tells us the label down here. 94.9 people per square mile. A population density says how tightly are people packed together. If you think about a high rise, oh my gosh, you have people stacked on top of people. So in 1 square mile, you could have thousands of people. In this case, we have 91.62 people per square mile. Consider, anytime that you're writing for your teachers on something that's being turned in, like your final homework draft, your final quiz, your final test, you want it to be as complete as possible. So you'll notice that I'm not abbreviating these. All right, during what year will the population density reach 94.9 people per square mile? Many students want to just plug in numbers until they get it, but this is an algebra class, and so we want to use this for algebra. You'll notice that this is a p number. So we're going to plug that in for p. We get 94.9 is equal to 0.82t plus 78.5. I need to isolate the t, so I'm going to get rid of the plus 78.5 by subtracting on both sides, showing this awesome work, which is very important. 9 minus 5 is 4. Decimals all lined up when adding or subtracting. Bowering. And 14 minus 8 is 6. 8 minus 7 is 1. Now, I do realize I have a calculator in my hand, which would be awfully important and useful, but I do want to make sure everyone is able to solve this without a calculator. So if I have 16.4 divided by 0.82, I never want to have decimals in the denominator when I'm dividing, so I want to multiply top and bottom by 100. That will move the decimal over 2 places and give me 1640 divided by 82. Can't write. 1640 divided by 82. It goes in there 2 times. 2 times 82. This work here is actually preparing us for chapter 5. Subtracting, and I get 0, 0, but because I haven't gotten this quite to the end yet, I need a 0 there. So I then get that the answer is t equals 20. Many students think that they're done, but the question doesn't ask what's t. The question asks during what year will the population density be 94.9. 20 is not the year. T is 0 for the year 2000, T is 1 for the year 2001. So we're going to take the year 2000 and add on 20. And that will give us the year 2020. Ta-da! If you want to use the prompt to write a sentence, during what year will the population density reach 94.9 people per square mile? In the year 2020, the population density will reach 94.9 people per square mile, period. Chapter 2, Section 1, Question 5, Type 2 of 2. Even though this is not an art class, you're still going to have to do your best to draw the pictures. So, we have happy face divided by plane minus snowflake equals book. And we're going to solve it for happy face. Now, there's a couple of different ways to solve it, but before we do that, let's try and solve it using a similar problem. So the similar problem, I have x over 2 minus 1 equals 5. If I were to solve x over 2 minus 1 equals 5, you might solve it by adding 1 to both sides, and then multiplying both sides by 2 to get the answer. So if we were to do that with this, I have happy face divided by airplane minus snowflake. By the way, snowflakes have base 6 points on them, is equal to book. So if this is a minus 1, I would do a plus 1. If this is minus snowflake, I would add snowflake to both sides. Here, I can add 5 plus 1 to get 6. I cannot add book plus snowflake, so I have to just write them as book plus snowflake. If you wrote snowflake plus book, that would be fine by the commutative property of addition. And then I can multiply both sides by 2 here. So I would multiply both sides by airplane. Now, be very careful. You would have to either multiply this one and this one separately, or put parentheses here, and then multiply it by airplane. I am okay either way. These will cancel out because they are multiplicative inverses from back in chapter 1. And we can have airplane times book plus snowflake. Or if you would, this is a perfectly fine answer, if you would like to distribute that, or if you wanted to multiply this by plane and this separately by plane because of the plus, you could distribute that and get airplane times book plus airplane times snowflake. Either of these is a fine answer. You could also have made a common denominator on everything, gotten rid of the denominator, and solved again. So there are many different ways of solving an algebra equation and still using the same rules that we've always been using.